बहुत सिंपल सी बात है कि फिजिकल एक्शन में जो पार्ट है बायोमैकेनिक्स का, दिस इज पार्ट ऑफ बायोमैकेनिक्स, फिजिकल एक्शन। ये जो फिजिकल एक्शन है इसका सोल ऑब्जेक्टिव क्या है? सोल ऑब्जेक्टिव है कि हम खाना खाते हैं और काम करते हैं, है ना। टेक फूड, आप फूड लेते हैं एंड वर्क करते हैं, ठीक है, ये जनरल चीज। इसी को हम साइंटिफिक लैंग्वेज यूज करें तो फूड क्या है? केमिकल एनर्जी। तो हम ये कह देंगे कि इफ इट इज ए मसल, तो मसल takes this one is a chemical energy, and that convert into the mechanical energy, तो फूड कन्वर्ट इनटू वर्क को साइंटिफिक लैंग्वेज यदि हम यूज करें तो वी call it the chemical energy is being converted into mechanical energy through the muscle machine. We call it muscle machine, है ना। कोई एक डिवाइस है, जैसे आप कहते हैं ना फोटो सेल, क्या है? फोटो सेल जो है वो सोलर लाइट को लेकर बिजली में कन्वर्ट किया। जनरेटर है, कन्वर्टर है, इन्वर्टर, ये सारे एक एनर्जी को लेकर दूसरे एनर्जी में कन्वर्ट करते हैं। तो दीज आर ऑल डिवाइसेस। तो इसी तरह से हम मसल्स को हम ये कह सकते हैं, ये जो मसल है, फॉर सेक ऑफ सिंप्लिसिटी वी कैन मॉडल इट कैन मॉडल इट। मान लीजिए ये दो मसल्स का एक छोटा सेगमेंट बनाते हैं, तो छोटे सेगमेंट में बहुत सारे टिश्यूज हैं जो इस तरह से कनेक्टेड रहते हैं, बहुत सारे टिश्यूज हैं जो इस तरह से कनेक्टेड रहते हैं, है ना। और इनके बीच में देयर आर सम डिफरेंट स्ट्रक्चर, जिसको हम केवल सिंपल मॉडल के रूप में आपके सामने रख सकते हैं। दीज आर अनदर कनेक्टिंग टिश्यूज, और इसमें जो नंबर है, जो नंबर एग्जिस्ट करेगा एक डेफिनिट डायमीटर में। एक डेफिनिट डायमीटर का मतलब, सपोज दिस इज ए डी diameter, and this diameter is also not very large, so this diameter is 10 to 100 माइक्रोमीटर। तो 10 to 100 माइक्रोमीटर है, तो इसमें इस तरह का जो मसल्स नंबर है, दिस इज 10 to the power 3, दिस इज द 10 to the power 3। और ये जो मॉडल हम कर रहे हैं, ये दिस इज द approximately in the length of 4 सेंटीमीटर। तो 4 सेंटीमीटर के मसल्स को यदि हम डिजाइन करें तो वी कैन डिजाइन इन दिस वे। और ये जो है बीच में, these are the some ligaments, जिसको हम कहते हैं they are connecting tissues, तो we can model in this way as the muscles। अब ये जो एक्शन है, मसल्स का जो एक्शन है, ये एक्शन आता है समथिंग लाइक, सपोज दिस इज this one, the spring, here it is also a spring, and with this spring there is a weight attached. Weight is nothing but mass into acceleration due to gravity, and this one is known as PEC. This one is known as PEC. EC is elastic constant. EC is the elastic constant. So this is the parallel elastic constant. This is EC is known as elastic constant, This is the elastic constant. So P stand for parallel. This is your parallel elastic constant, and this part is SEC. SEC. This is known as S stand for second elastic constant, and this part is CC. This part is CC. CC is as contractile component. Contractile component. Contractile component. तो क्या हम इसमें देख रहे हैं कि हमारे पास जो साइंटिफिक लैंग्वेज में हम फूड को कह सकते हैं केमिकल एनर्जी, और जब हम इस फूड को टेक करते हैं और तब काम करते हैं, आदमी क्या है, आदमी खाना खाता है और इस तरह से काम करता है. इट टेक्स द फूड एंड डू द वर्क. इसको साइंटिफिक लैंग्वेज यदि हम दे दें तो दिस साइंटिफिक लैंग्वेज इज take the chemical energy and do the mechanical work. अब through the muscle, तो मसल को कैसे हमने आइडेंटिफाई किया? These are the design, and this part in this design, this part is known as, this is the myosin. This is myosin, and these part is known as actin. So myosin and actin, these are proteins. These are the proteins which are the form of the myosin and actin, and form of the ligaments and our tissue, and these are the modeling of muscle. अब इसको हम फिजिकल कॉन्सेप्ट से इसका एक्शन को यदि एक्सप्लेन करें तो हम इस मसल्स को इस तरह से एक सिस्टम के रूप में एक्सप्लेन कर सकते हैं फॉर फिजिकल डिस्कशंस. दैट इज देयर आर वन स्प्रिंग which is parallel to the contractile component and second elastic constants. So this one is as ये जो डायग्राम हमने बनाया है, इस डायग्राम का एक फिजिकल डायग्राम ये हो गया. अब इसमें हो क्या रहा है? What is going over here? We consider stated muscle a series of bundles visible along the fibers called sarcomeres. This is 40% of the weight of human body. तो यदि हम किसी व्यक्ति का मास 40 kg है, someone is 40 kg, so this MS is 40%. 40% का मतलब 40 into 100 into 40. So this is cancelled, that is 16 kg. 16 kg are the muscles. From the myofibrils, the filament made up of protein that is दो प्रोटीन का हमने नाम लिया, मायोसिन एंड एक्टिन, मायोसिन एंड एक्टिन. The thickness and thin filament are mechanically coupled by cross bridge, which is a projection from thick filament towards thin filament. Towards the thin filament. So these type of muscles, first is there are two types. First is isotonic and second was is isometric. So these are what is isotonic? If the load on the muscle remain constant, during the time and it contract, then such type of muscle is known as isotonic. Isometric, the ends of muscle are held rigidly and fixed so that does not allow to change. Then such type of muscles are known as isometric. So these are the two different type of the muscles. Broadly we are called at broadly because we are not going to discuss the microscopically. Now, the scientist A.V. Hill studied extensively and observed that when an adequate external stimulus is applied to a muscle, the initial response for short period of time called lateral period. So in isotonic contraction length begin rapidly, and then the rate of contraction falls down gradually as it is the shorten. Means if this one is the size, and during the contraction, if it is the contracted, so the rate of contraction will slow. Here it is slow rate of contraction when this length is slow, and here is the normal, that is called rate of contraction. So say if it is the X and here it is XM, it is the X and there is a XM, then the reduce in the length, that is X minus XM, the rate of contraction at any moment is expressed as v velocity, that is rate is k constant x minus xm, and this one is represented as, कैसे इसको represent कर सकते हैं? So earlier we have one diagram. We can say this diagram is, suppose these are the actins, and in between actins, here it is myosins. These are the myosin, and elongation, if it is elongated, so during the elongation, this kind of the formation is there. And for another shorten, these are the part. and these are the part. So these are the action that is taking place, and this action has explained with the help of this spiral spring. So the speed is large when contraction just begin to falls to zero, as contraction approaches its maximum possible values. Thus, from above equation, we have that is velocity v of t is equal to dx by dt, and that is kx minus xm, or x is equal to under root dx by dt into t. So this is xm plus x0 minus xm into e raised to the power minus kt. Where x0 is relaxed length of muscles, x is equal to x0 when t is equal to 0 before start, and this constant k is called shortening constant. This k is called as shortening constant. This k is called as shortening constant. So in this way, we have the power. We have the power that is called muscles power. The energy is converted muscles spends energy in the process of contraction. The energy is spent in two ways. First, the work done in lifting a load, and as heat release. that is the microscopic objectives. The second part is it involves molecular dynamics and hence can be estimated at present only from experimental data. And the heat dissipations and the muscles characterizations is proportional to the contraction. So the amount of heat released during muscular contraction is given as delta Q is equal to A into delta X. Where A is empirical constant. Work done in lifting the load of effective mass by a distance. Delta X is delta work done, that is m into g, weight into delta X is h. So the total energy is delta E, and this is delta Q, heat released and work done, and this is A into delta X plus mg into delta X, that is A plus mg into delta X. Power of muscle is energy spent per unit time, that is P is delta E by delta T is equal to A plus m of g into delta X by delta T, that is A plus mg into velocity. Velocity is equal to dx by dt. Velocity is equal to dx by dt. So equating the power equation, we have P is equal to A plus mg into V is equal to B m0 minus m into g. So this is the load. This part is the load lifted load lifted depends upon the difference between the maximum load and actual load. So what here it is A into V plus mgv is equal to bm0g plus minus bmg. So we can have A V plus mg into V plus b mg is plus some constant AB is equal to bm0g plus AB balancing factor as we have adjusted here. So by simplifying, we have A plus mg and this is V plus m. V plus B is equal to A plus m0g into B. m0g into B. So this one is the fundamental equation the fundamental equation of the muscle contraction is A plus mg into V plus B is equal to constant. This is constant. So V plus B is equal to constant C upon A plus mg. So this is your speed. So this is your speed. So what is the speed? This is constant upon load. This is constant upon load. So this one is the way to extend this part is, and what we find the speed is inversely proportional to load. Speed is inversely proportional to load. So as the construction of the muscles is there, which vary as per the load, and this is all about the today lecture, that is the muscles power and muscles power of the human body. This is 40% of the weight is muscles, and this is today lecture.